does help us account for what the distribution. Our model, though, is going to look at density of dentists, while also, and the statistical process is adjusting for the proportion of kids who are receiving preventive dental care from 2007 to 11, the proportion of kids receiving preventive dental care from 2011 to 2016, and those without health insurance in 2008, whether health care was affordable or not for that state, and the region. Because we know that there already is geographic variability, so we're going to adjust for other variables that we know. We're adjusting for the other variables that we know have a relationship with the proportion of kids receiving preventive dental care. So now we put them, these are all the slices of pie. It's almost like we're trying to build a puzzle at the same time. Do all of these slices of pie fit this particular pizza pie? Just because you find a slice of pie doesn't mean it came from that particular pizza pie. It might have come from a different pizza pie. So the question we have here is, if I bring all of these guys together, do they independently come from this pizza pie? Do they help me address the variability here? When we ask for these covariates and then start to parameterize our model in this fashion, so first in our model builder, all of the variables that you put in here come under here into block 1. We make sure that that's the first for you guys. When we're building models, they can become far more complex than what we're trying to do right now. Oftentimes you do them in stages or blocks. So you might say, I'm going to fix some variables into my model. You cannot take those out. For example, let's say age or other demographics. Those have to be in the model. That would be block 1. And then we want to find out if I add another variable into the model, will it significantly help it or not? That might be in block 2. Then block 3 might be, again, adding additional variables to your model to see, do they help me add to the performance? If not, then I take it away. If they do, then I keep it. So once you add variables in here, they're going to be added into block 1. I'm just going to say, let's keep that. We won't be adding any additional blocks. This is not going to become a more complex model building process. Okay. In terms of our reference levels, any variable that you put in here in your factor level that's not continuous, it's categorical, you've got to compare one level, at least, with another. So your affordability and your region, these are not continuous variables, they're nominal variables. So you have to pick one of those levels as a reference. Who are you going to compare it to? All the other levels. So for the affordability, I'm going to say let's compare against affordable. So whatever the metrics are for this variable, it will be not affordable versus affordable. And then for region, I'm going to pick Northeast as the reference level, which means whatever the performance metrics are for this variable in our model, it will be Midwest versus Northeast, South versus Northeast, and West versus Northeast. This is only one way to build our reference levels, but let's choose to do this. It's the simplest. Okay. Finally, as with every statistical test, there are assumptions that we need to keep in mind. And so the assumptions that we have here are an autocorrelation test, collinearity statistics, QQ plots, residual plots, and Cook's distance. Again, your final exam only covers up to correlation. None of what we're discussing right now do you need to commit to memory or RAM, but when you're ready to come back and revisit it, please do so. It is exciting. It's fantastic. But the most important assumption that we need to check for is collinearity. Collinearity says, now hang on a second. These are all independent pizza pie slices. But let's say when you actually found two pieces, they actually were one larger piece that somehow broke when you found them on another table or something like that. They were actually one slice of pie though, but what you found were two slices of pie. The collinearity statistic says if two of your independent variables are actually related to each other, you can't have them in the model. You can only have one of them. If you have two variables in the model that are related to each other, you have what's called overfitting in the model. Your model looks better than it really is. Okay, overfitting. So when we test for collinearity, it's really important because you never want to propose or share something that looks better than what it really is. One of the things that we've been doing throughout this entire class is handicapping ourselves, right? With degrees of freedom or making it harder to reject the null hypothesis than it really is. We never want to go in the other direction where we say, hey, there's a difference when there really isn't one. So collinearity really helps to make sure that we don't do that. Say our model is better than it really is. So again, if two variables in your model are related to each other, if you have them both in the model, it's like cheating. It's like they're whispering answers to each other, right? And we don't want that. So we can only have one of them in the model if they're related. And collinearity tells you if two variables are related to each other. Then finally, you want to find out how well your model actually fits the data. Okay. If the model fits the data well, that's great. You can use the model to describe your data. If the model doesn't fit very well, we ought not to use it. So for model fit statistics, if we ask for let's say an R squared, that R squared will tell you the proportion of the variability in our dependent variable that we can account for. The closer to 100% or 1.0, the better. The closer to 0, our model doesn't fit very well. It's not accounting for variability in our dependent variable.
Why do we use R squared when we could just base it off of R?
Okay, R only tells us whether two variables are going in the same direction. But remember how the points on the line kind of tell us how far away? Right. The R squared tells you the summary of how far away are those points from that best fit line. R simply tells you the degree to which they're going with each other.
But wouldn't it, if you have a more positive R, a stronger R, you would always have a higher R squared?
Yes, that's true. It's true. So can you use R? Yes. But if you use R, it's not telling you the coefficient of determination.
Okay.
It's only telling you the degree to which they vary with each other. The R squared tells you the actual proportion of variance in your dependent variable that you can account for.
Got it.
The F test is just like your ANOVA F test. And that's that measure of between group. Sorry. I get a new laptop this week. I just got an email on Friday. It's ready. So, sorry. This guy, in case if you get cold in your California winters, you're more than welcome to borrow this laptop. It heats up like a mother. So if you want it as a heater, you're more than welcome to have it. The F test is just like that F from ANOVA. And it tells us if the between group variation, the signal, is more than the within group variation. So yes, all our variables vary all over the place, but the idea is here's this dependent variable. Are we able to account for that signal more so than the variation that's happening within our groups? The F test will tell us whether we can do that or not. Then finally, for our model coefficients, let's ask for the things that we typically always ask for, 95% confidence intervals around the estimate. You know the slope that we're trying to get out for each variable, whether it's non-zero? We're trying to build a 95% confidence interval around that too, because we know that these are just estimates. We don't know what the actual value is. So give us a 95% confidence interval around that estimate. Okay. Good so far? Yes?
Can you explain the F test again?
Sure. So just like with the ANOVA, the between group variation over the within group variation, if that ratio is big, that means there's a lot of signal that we can account for. For our model fit, that's also telling us you're accounting for a lot of the variation that exists in the model, the variation that actually matters. So if this F test is big, or if the p-value is small, that means this is a really good model. This glove really does fit the hand. Okay, so after you're done parameterizing, over on the right-hand side, you get the actual outcomes of what you've asked for. So here in your linear regression, the first table tells you your model fit. Does the model I built actually fit the data that I have? And here are R squared values. This is real data. R squared value is 0.694. We can account for nearly 70% of the proportion of kids who are receiving preventive dental care in 2016 with these covariates. Density of kids in 2016, or density of dentists in 2016, the change in the proportion of kids receiving preventive dental care from 2007 to 11 and 2011 to 16, and the proportion without health insurance in 2008. Not the proportion without health insurance later, but for those without in 2008. Then also region and affordability of health care in that state. Okay, so we have a very good model that can help us account for at least 70% of the variability in this dependent variable. That's quite meaningful. Does it work? So this is high, but does it work? Just going over with this F-test, the F-test says yes. P-value less than 0.001. And what kind of evidence is this?
Extreme, or very strong.
Extreme, very strong, overwhelming evidence against the null hypothesis that this model does not work. It cannot account for a significant amount of variation. But these tests tell us it can, nearly 70%. But do all of the variables in our model help us to do this? And this is where we want to jump down to our omnibus F-test. And also, right, there are a lot of stats there. So the bigger the model you want to build, yes, the hairier your tables begin to look, but they're all telling you the same thing. It's just for every single variable in your model. Now there is something called, there is a term called parsimonious model building. And what do you think parsimonious means? Has anyone heard that term before? Especially those who've had a stats class before. Yeah, it's related to parsimony. Any musicians here? Sorry?
Parsimony.
Parsimonious, at least in terms of mathematical and statistical model building, parsimonious means we're trying to build the most elegant model possible, and that is with fewer variables. No more variables than you actually need. No more notes than you actually need. So you're really trying to go for this effect where we're doing really well with the least of what we should actually have to use. And so a parsimonious model is a model in which you don't try to add more variables to it. You try to use the smallest number of variables with the biggest bang, or to account for the most variance in your dependent variable. So what we're trying to find out is if we have a parsimonious model by making sure that none of the variables in here are contributing nothing, right? We know what we wanted to see in our model, but now we need to go through and make sure that every single one of these is contributing something to our model, because if not, we need to get it out of there and then see what happens to our model once we get it out. So here in the ANOVA test, we're going to go one by one with each of our variables and find out over here if they're contributing to the model, contributing to us being able to account for signal. So let's start right at the top. Density of dentists in 2016. We're going to run all the way over to the F and associated p-value. And what does the p-value say for density of dentists in 2016? Does it help? The p-value says what? Is it significant?
Yeah.
No. The p-value is greater than 0.05. This p-value is greater than 0.05. So it's telling us that although we have a really good model accounting for 70% of the variability, and with a p-value of less than 0.001, density of dentists, though, is not contributing to that model, and we can consider getting it out. So the whole time, this entire course, we've been looking at the density of dentists and wondering if the density of dentists helps us to be able to predict, or at least account for, proportion of kids receiving preventive dental care. And we're finding that if we have these guys in the model, no, it does not. Does that strike you as odd? Are you surprised by that? Not really? Well, let's find out if who else needs to go.
Just means policy.
Seems plausible?
That means that policy is more important
This
than the
means that policy might be more important than the actual density of dentists when it comes to proportion of kids receiving preventive dental care after ACA. What about the affordability of healthcare? Is affordability of healthcare meaningful? Is this even on? I don't think so. The battery's gone on this too. What about the affordability of healthcare? Does affordability of healthcare help? Let's jump all the way over to an F. Looks really small. P-value says 0.541. It's above 0.05.
Yeah.
It's above 0.05. So, should we keep it in the model? Should we keep it in the model?
No.
No? No. Just get rid of it. Two of the variables that we thought mattered the most up to this point. One we say, but let's ask about other guys too. In the presence of these other guys, these two don't seem to matter. Okay? And that's the power of statistics. It's really important sometimes when you ask one question, sometimes maybe two questions, but when you feel like you're able to ask several important and related questions, you then get the opportunity to compare them to each other and see who really matters. And when it comes to the statistical variability in the proportion of kids receiving preventive dental care, density of dentists does not matter. Affordability of healthcare doesn't matter when we know this other information. Question?
I was asked if you had a delta for density of dentists.
We could have, one of the nice things about model building is whatever comes to mind, you can test for it as long as you have that data. So if we want to look at the change in the density of dentists, because some areas actually saw a boost or an increase in the density of dentists, that might help to account for the proportion of kids receiving preventive dental care. It might not, but we get an opportunity to test for it since we have that. Okay, so let's keep going down the list. What about the change in the proportion of kids receiving preventive dental care before the Affordable Health Care Act to just after it? Does that help us to predict the levels after the Affordable Health Care Act? This model says, yes, it does. What about the change from 2011 to 2016? And we know they're different because we tested. They're very different. Does that help? This says, yes, it does. Question? Way in the back? No? What about those without health insurance? And we looked at the other years, the more recent years, and they didn't seem to help. But the earliest time point we had for 2008, just before ACA, again, probably the states and areas that are contributing to the policy analysts who are thinking about what would be helpful for the whole US. Yes, those without health insurance, that variable seems to help predict proportion of kids receiving preventive dental care in 2016. So here, this ANOVA test tells us which of the variables seem to really be helping and which ones are not. Okay? And so here, the two variables that we had our eye on as probably being the most important for proportion of kids receiving preventive dental care, in a full model, we're finding that they are the least important. And in fact, they don't help at all. So what we were seeing before is something that we would call artifact. Looks real, but it's not. It looks significant, but it's not. It actually might be due to something else. When you want to actually build your y equals mx plus b equation and then share that with others and see if that helps them, that comes from this table down here, your model coefficients. So if you look at your model coefficients, this first column tells you what your variable is that's in your equation. And that first row is that intercept. Remember y equals mx plus b? B is that intercept, where we cross the y-axis, where your line crosses on that y-axis. The beta-intercept, or that y-intercept here, you grab from this column. That estimate is 0.8640. So your y equals mx plus b. Take the b out. I apologize. Well, this is the last time this is going to happen to us. Take the b out and put this 864 in instead. And then that y equals mx plus b. Now remember, we have multiple mx's. We have y equals m sub 1 x sub 1 plus m sub 2 x sub 2 plus m sub 3 x sub 3. However many variables you have, that's how many mx pairs you have in your regression. Your next one would be density of dentists. Look how small that estimate is, 0.002. And we also know that, again, the p-value, 0.538, not significant. So right now, you would have to build your model this way, even though these two, density of dentists and affordability of healthcare, are not significant in the model. But when you go back to redo this and you take these two out, we can see if anything changes in the estimates for these guys or for the statistical performance. Okay, so what I want you to come away with right now is the idea that regression isn't that far of an extension from correlation. So if you can do correlation, you can do regression, especially if you have software like Jamovi. The second thing is, it's really important that you move on from correlation, because correlation is not causation. Regression isn't causation either, but regression allows us to make sure that these guys, in the presence of other important variables, ask the question, do they really matter? Does it really matter? And what we found is that the two that we had our eye on, they don't matter in the presence of the change in the proportion of kids receiving preventive dental care, whether they have health insurance or not the affordability of it, just whether they have health insurance or not, and the region of the US. We good so far? Sort of? I'm seeing head shakes. Head shakes. Not good, not good. This is done on a daily basis, not just for policy level clinical models, or policy level models, but for clinical models. So when you try to determine whether a patient is likely to return, pay on time, come back in worse shape or worse situation later, this is the process that's used to make those predictions. Credit scores, whether you get the fancy card offered to you or not, it's all based on regression models. What I want to do right now is to show you what happens when I take the two variables that we know don't help out of our model. So density is going to come out, and affordability is going to come out. And when I take those two out from our model, our R-squared drops from, where were we? Because right now we're at 69.1%. And when we had the other two that we were so confident about before, what was our model? 69.4%. Is that a major drop to you, 69.4 to 69.1? No, which says if you get rid of having to hang on to those two variables, you're not going to lose much. We now have a more parsimonious model by getting rid of baggage that we don't actually need. Unfortunately, what we got rid of was what I thought I needed the most. And that happens so often when we're building models. I hope you guys take whatever you're working on in terms of research this year, and you're able to think of some kind of model that you might be able to test or build at the back end, because it will blow your mind when you find that what you thought was the case statistically ends up being something entirely different when you can see the underlying patterns using statistical models. That's all I wanted you to get from regression. Don't expect you to be able to do this on the final exam. Don't expect you to be able to do it later this afternoon. Don't expect for you to think about this at all again until someone confronts you with a decision they've made for where you fit in a model. And then you say, hey, I want to revisit that class again and figure out what happened. Because there's a way to game the system too, on the other end. Okay? So if we're done with this, I want to take questions from you about either Cheryl Willard, what's due, or the final exam. Data is being made available this Friday, and you have until Wednesday at 10 a.m. to turn that in. And then also your group project, which is due, I think, 2 days after your exam. So that's the Friday. Plenty enough time to kind of fit in this work around your other clinical responsibilities and your clinical final exams. Okay. Any questions for me?
regarding the group project,
Group project.
we sent, so we did that initial group form discussing what we wanted to do.
Right.
We
So-
already have those data sets.
You have partial. Some of the data sets available in there, it might not be for your group, but some of the data available was regarding the proportion of kids who have received dental sealants. I think there's some adult variables in there as well too. That's the complete group project data set.
Okay.
Your group though may not have wanted to use any of those variables for their question. Right? So that's okay.
Okay, but everything else we should have.
Everything else you should have.
Okay.
But the final exam will incorporate some of those new variables.
Got it.
So if your group did plan to use some of those new variables, that would be good because it will help prepare you for what will be on the final exam. If you've been alive in our class, you should be well prepared for our final exam. Yes.
On that paper that we submitted, you have here like other variables like insurance carrier.
Yes. Insurance carrier is a new one. Insurance carrier is a new one. But again, for your statistical question, you may not have needed that.
For the one I picked.
For the one you picked, right,
Like
exactly.
you said in the final will be.
But in the final exam, that variable is featured.
So is there something I need to know about that?
No.
Okay.
No, except that it's a nominal variable.
Okay.
And so if you're proposing, if I'm asking you to use that variable along with another variable, you should know where it goes in Jamovi so that you can, exactly, yes.
So for the final, is it gonna be like, pretty much like all of our assignments where you just tell us like what variables we're using and then we just have to go back into the PowerPoints and fill in those?
Right. I might not tell you, like in the assignments, I told you what the variable was. I told you it was a nominal variable. It's your independent variable, it's your dependent variable. On the final exam, I won't tell you if it's the independent or dependent. I would simply say, I want you to compare this variable between the levels of this other variable. So you have to know where in the independent box or the dependent box to put that variable in Jamovi.
Okay.
That should be fairly simple though.
Yeah.
But yes, it'll be very much like the assignments, the lab assignments, very much. Back there and up here. Yes.
Is there any way that I figured out
I'm sorry?
about this project?
You're
To figure out what? Sorry? So the data for the group project will be available this Friday.
Oh, that's the same for research? I got it, okay.
yeah.
It won't be the same for your research class.
No, you made
No.
it that way.
Oh, you guys did? Oh, smart thinking. All right. Fantastic. Double duty. All right. Yes.
The final will be timed,
Let's take home.
Take one.
No, let's take home.
so it's just gonna be like a Jamovi assignment.
It'll be just like a Jamovi assignment. You just need to submit it by the due date. Yeah, and that will be a hard due date time. Yeah. Yes.
When can we visit your office for the workbook?
Oh, when can you come by so I can check your Shara Willard? Anytime up until the 16th. That's when it's due. Well, if you want to see me in person though, it's got to be by the 14th.
Okay. Can we email you this
yeah,
up
you
too?
can email
Oh,
me.
okay.
Yes.
If it's like a hard copy, how would we give it to you if you're not?
If it's a hard copy, come by and show it to me, but I don't want to hang on to that. I'm terrible with paper. Yeah, and I don't want to hang on to it. So, yeah. But if you got a hard copy, and you might want to keep that, so just come by and show it to me, let me see it. Yeah.
Use
Yeah.
blue paper. Use blue paper. You don't use it.
Blue paper and I won't lose it. Any other questions? No other questions? All right, well, it was a joy to work with you. You are a fantastic class. I don't think I've received as many good questions as I did in your class and I have in previous classes. Please don't tell them that. I know some of you know them, but you guys were fantastic. You've done really well on the quizzes and exams and assignments. This is the first time I've used actual software in a class, and you guys took it like ducks to water. You should be really pleased with yourself. Really pleased with yourself. is it doesn't. I hear it's not supposed to be this easy of a transition, but I have no complaints. I know you do, and you're welcome to share those on ways that this course can be better. And we do take those into consideration, and we try to factor in and make those changes. So, be honest. Be honest. If you haven't done so already, did they already have you do it?
Yeah.
Oh, it's too late. Oh, I'm still gonna respond to your feedback. Yeah.
Thank you.
You're welcome. You're welcome. Some birthdays in here. Happy birthday. We got some twins here. Very nice. Did you guys have a good Labor Day weekend? Anyone do anything exciting?
Newport Harbor.
Pearl Harbor?
Newport Harbor.
Newport Harbor. Okay. Did you get on the water? Nice. Okay, I can tell.
Yeah,
Got a
you
little on
get-
the nose there. Yeah.
Wait.
Anyone head up to NASDAQ? A couple. All right. Was it good? Good. Excellent.
Can you drive with fly?
Alrighty then. With that, you have. Do you have a follow-up class?
No.
No, 10 o'clock. You're done for today.
You today.
Should have told me. We could have done this before your Labor Day weekend. You could have had an extended.
Oh.
You guys got to communicate better. Who's your communications officer? Sorry, guys. All right. Well, I will see you. Some of you.
Later.
Before, yeah, I should see some of you this week. Hopefully, I should see all of you by the end of next week, if I haven't seen your.
I'm gonna make a quick announcement, guys. Hello.
Hey, Lucia.
Would you guys think you guys will be here September? I know it's before class starts, but September 20th, if we had a Vespers at Dr. Moretta's house, or is that's not a good move?
That's fun.
That's fine with me.
September. Who do you think will be here?
Let's do a hand
If we do like
raise.
that Friday night, who do you think will? September 20th.
I'll be here. I'm not going nowhere.
Yeah, it's right before break.
Before break.
Like after break, right when break ends, the weekend.
It's the last weekend of break.
Okay, raise your hand just one more time. Just so.
It's the last weekend of break, right?
Yeah.
So that Monday,
Oh,
that Monday
Okay.
we would start.
We'll do it again. We'll reconvene again then the third weekend of August then. Yes, it's no October. One more announcement. I just wanted to update you with you guys about NASDAQ convention that Sabina and I went to. I don't know if you guys know what SNASDAD or NASDAD's about. It's an organization that dentists and dental hygienists meet, and their goal is to support dental clinics around the world. So which is really cool because there's a lot of clinics that don't have, like say, instrument chairs or hand pieces, and what they do is they learn the needs in different countries and they provide for the needs in those countries. And it's really cool to be a part of that kind of a team. And so I don't know if you guys are interested in that, but you can start in SNASDAT and going to those meetings and hearing about these different places. And also it's great networking, meeting other dental teams around the state. And if you want to work there, you can. If you want to go somewhere else or not.
What was your guys' favorite part about running?
I think networking. I was able to meet somebody so I can go to Lake Tahoe and snowboard. I don't know, for free. So that's awesome. Like to stay someplace because it's really expensive out there. There's a lot of networking you can do. There's a lot of people around the area, and there's a lot of people that are looking to give their practices or find dental hygienists to work with them because they're getting older and they need people. So it's such a great tool, and they're all Christian based, so they're really big on reaching the world for God. So, which is so good because we have the resources like hand pieces in all these places, but some places they need us to send them the equipment. So, if you guys are interested, please let me know.
They're also the group that pays for our mission.
Yes, they're the ones that pay to the mission trips to go. So it's a cool organization to be a part of and to learn more about. Okay? Just let me know if it's something you guys would be interested in. Also this weekend on Friday, there's a SNASDAD Vespers. at one of the professors' houses, I believe. So I will be posting a thing on Facebook if you guys are available in the area. Please go. You just never know. Yeah? Okay.
Where's it at?
I'll post it. I'll post it. It's at the Drayson?
Thank
It's at
you
the
so-
Drayson.
All right, thank you.
Bye.
Hey,
I almost gone.
so to my house, drove down, the rest of that food. Catalina, Mama looks good.
Laura.
Fine. Good.
Hi, girl.
I don't know, it's really nice. I think
Evan, how old are you? 30?
I can't give over there.
How old are you? 40?
That doesn't make sense.
Where are you going?
Did you hear the
25? Oh, man.
I woke up today, my back is hurting.
Get ready for that the rest of your life. Bro, I'll cut you.
Bro, it's right there. It's gonna take me like 20 minutes.
Yeah.
If she doesn't give it back, what about Barry?
But, yeah.
I mentioned
Sam counted it when I think none of us are doing it tomorrow, so we can go during that.
I told her and Wednesday as well. Can I show you guys? I suggested that too.
That might be better.
I want to continue.
We all go.
Yeah. And then if they feel like
Since this is the final, like, kind of draft, like, thing, so yeah, Friday, yeah.
You want to come to my house?
like give me some time.
It's just different modes of learning, but I think I prefer the interactive.
10 o'clock.
Wait, so I started my own.
I didn't even start.
Or 3 o'clock.
Yeah, I was still working on the buses.
It's me.
Maybe like ask the question, but it's something, right? Like, just be like, not really make that work.
Were we talking about meeting with Dr. Benier?
Yeah, but
I mean, you want to come to my house and get your food?
we don't have
Depends on between our research
and none of us should. So I'm not with Sam, who will be here. I know, but we can that way, like everyone will be here. Considering how to find out.
What? Same meeting in town?
Okay.
Sorry?
Let me. How did you
No, I just emailed Dr. Benier and then I think he's done.
Negative are strong. No, it's a word. Kinesthetic is not Silence is important. The first? Okay. Free concept. Oh, yeah. Okay, yeah. So anyway, like, you said, like,
It works. I just want some flavor.
Yeah, he's got this camera up.
I didn't know.
I didn't know it was like social media, but I think so much.
Yeah, you put it back on. Oh, so John's book. Okay, I see what they're applied to.
Oh, did you actually know someone personally?
Yeah.
Can I give me a name?
I know. Well, my name is
Okay,
John.
so you want who? No, you're not allowed to look at that. What's his name? John who?
UA, I think.
Oh, right. That's the.
Do you know him? Christian. Not like. Is it really?
So I don't know that one
Okay, we can stop looking.
I get it.